So very good morning, all of you. So we are discussing about the course concrete technology. So today we'll see the first module, which includes cement, admixtures, and aggregates. In the first module, whatever we have discussed in the previous one. So from today onwards, we'll start the module 1, right? So this first module contains. So first we'll discuss about the cement. So that is basically Portland cement and admixtures, different types of admixtures and aggregates. In the Portland cement, so we'll discuss what is the chemical composition, what is the hydration process of the cement, setting of cement, structure of hydrated cement, tests on physical properties and different grades of cement. So these things we will discuss in the Portland cement. So let's come to the admixtures. In the admixtures, we'll discuss what is the mineral admixtures and the chemical admixtures. So generally we'll use in the produce the concrete. And what are the properties, the different properties of mineral admixtures and chemical admixtures. So doses, how much doses we need to use in concrete, and what are the effect. What is the effect? So if you are using mineral admixtures or chemical admixtures, what are the different effects in the concrete? So those things we'll discuss. And let's come to the aggregates. So in the aggregates, we'll see the classification of the aggregates. So we have two types of aggregates. One is fine aggregate and coarse aggregate. And particle shape. What is the particle shape? What is the bond, texture and bond, strength and other mechanical properties of the aggregate. So that is specific gravity of the aggregate, bulk density, how much bulk density of the aggregate, porosity, absorption, moisture content of the aggregate, bulking of sand, and deleterious substance in the aggregate, soundness of the aggregate, alkali aggregate reaction, thermal properties of the aggregates, sieve analysis, fineness modulus of the aggregate, and the grading curves, different grading curves. So based on the sieve analysis, we have different grading curves. What are those grading curves? And the grading of fine aggregate and coarse aggregate. So what is gap graded aggregates? So these things we'll discuss in the aggregates. So first and foremost thing is cement. So what is the cement? So we'll discuss today class. We'll discuss entire thing about cement. So Portland cement, the chemical composition, hydration process, setting of cement, structure and hydrated cement, tests on physical properties and different grades of cement. So in this we will discuss all those things. Apart from this, we'll see the manufacturing process. What are the different manufacturing process of the cement, and what is the chemical composition. So those things we'll discuss. So first of all, what is the definition of the cement? Why it is called as cement? So cement is the mixture of calcareous and siliceous and algareous and other substances. So cement is a mixture of calcareous, siliceous and argillaceous and other substances. So cement contains lime, silica and clay. So in other words, it's lime, silica and clay. So cement is used as binding material. Cement is used as binding material in the mortar and concrete. So what is the history of the cement? So from which year it is come up? So let us see the history. So lime and clay have used as cementing materials in the construction throughout many centuries. So especially the Romans. So Romans are invented these kind of cement. So Romans are commonly given the credit for the development of hydraulic cement. And most significant incorporation of the Romans was the use of pozzolana lime cement by mixing volcanic ash. So they have used volcanic ash to produce the cement. So from which mount? So Mount Vesuvius with lime. So they have used volcanic ash and lime to produce the cement. So best surviving example of what this is Pantheon in Rome. So in 1824, Joseph Aspradin from the England invented the Portland cement. So this is basic history of the cement. So in 1824 itself, they have developed the Portland cement. So in India, if you come to the India, the Portland cement was first manufactured in 1904, so near Madras by the South India Industrial Limited, but the venture was failed. So 1904, it was failed. So in between 1912 and 1930, so India Cement Company Limited was established at Porbandar, Gujarat, near Gujarat, and by 1914, so this company was able to deliver. This company is able to deliver about 1,000 tons of Portland cement. So 1914, the first company which is produced by 100 tons of Portland cement is India Cements Company Limited. So by 1918, the three factories were established together with they were able to produce 85,000 tons cement per year. So this is the history. In India, what is the history? So that's what we are discussing here. So during the first 5-year plan, 1951 to 1956, the cement production in India is rise from 2.69 million tons to 4.6 million tons. So in the years of 1951 and 1956. So by 1969, the total production of the cement in India was 13.2 million tons. 13.2 million tons, and India was occupying ninth place in the world. Ninth place in the world in 1969 itself. So what about current status? So this histogram shows the current status, how much cement is produced in India. So if from 2008 to 2022. In the 2008, it was 174.3 million metric tons. In 2009, it is 186.9. In 2010, it is 206. And it has come up in 2016, 274. 2016 274, 2017 273, and in 2022 it was 381 million metric tons. So how much infrastructure is developing, you can see by looking of this histogram, right? So this is what the India production as of now 2022. So India is producing 381 million metric tons of cement per year. So cement is classified into two varieties. Cement is classified into two varieties based on its hardening and setting mechanism. Based on its hardening and setting mechanism. So these are, one is hydraulic cement and other one is non-hydraulic cement. Hydraulic cement and non-hydraulic cement. So if you come to the hydraulic cement, what is hydraulic cement? So hydraulic cement is an inorganic material. Hydraulic cement is an inorganic mineral material that reacts with water. That reacts with water under ambient conditions, forming a hardened and water-resistant product. Water-resistant product. So let us see once again. So hydraulic cement is an inorganic mineral material that reacts with water under ambient conditions, forming a hardened water-resistant product. So this is what the hydraulic cement. So the cement hardens by hydration in the presence of water. So this hydration process will develop within the cement in the presence of water. So the examples for the hydraulic cement are Portland cement, blended cement, blast furnace slag cement. So different types of cements. So this cement will react with water. So hydration process will occur within the material, and it hardens. It hardens and it will become water resistant product. So this is hydraulic cement. So if you come to the non-hydraulic cement, non-hydraulic cement. So as the name indicates, non-hydraulic cement, as the name indicates, The non-hydraulic cement does not require water. Non-hydraulic cement does not require water to harden. So previously hydraulic cement it requires water. So compulsory it requires water. Why? Because the hydration process has to occur, right? So for this hydration process, we need water. So for hydraulic cement, we need water. But non-hydraulic cement, we don't need any water. We don't need any water to harden it. So it will not set when wet conditions are exist. So it won't set. If you add the water in non-hydraulic cement, it won't set. So it instead all needs a dry condition. It all needs a dry condition and the presence of carbon dioxide to set and cure. So we need dry conditions. We don't need wet conditions for the non-hydraulic cement. So we need dry conditions and in the presence of carbon dioxide. And in the presence of carbon dioxide and it set carbon dioxide to set the and cure. Then only it will harden, right? So, for the non-hydraulic cement is slaked lime and non-hydraulic lime putty. So all of you have seen the putty, right? So it requires dry condition. It requires dry condition to harden it, right? So this is about hydraulic cement and non-hydraulic. What are the uses? What are the uses of non-hydraulic cement and hydraulic cement? So these are the uses for the non-hydraulic cement. So non-hydraulic cement is used for making bricks and mortar. Non-hydraulic cement is used to making of bricks and mortar. Sometimes it also used in the stoneworks. Basically, you find these use of non-hydraulic cement only indoors as that was the only place where you can ensure dry conditions necessary for its curing. So non-hydraulic cement, we need dry condition. We need dry condition for curing. So and we need carbon dioxide. In the presence of carbon dioxide and dry condition, it will harden, right? So hydraulic cements, the use of hydraulic cement due to less reactive nature of in curing. So it is used for building building of dams, swimming pools, drainage systems, right, and buildings, bridges, and so on. So any structure, any big structures, so they are built up by using hydraulic cement, by using hydraulic cement, right? So all major civil engineering projects, they are using hydraulic cement. So what are the raw materials? Raw materials we use for the cement is one is calcareous materials and argillaceous materials. Calcareous materials and argillaceous materials for the raw materials we use to make cement. And calcareous materials are limestone or chalk, so marl or marine shell. So these are the calcareous materials. And argillaceous materials are clay, shale, slate, and blast furnace slag. So by using these two materials, we will make the cement. So the temperature to make the cement is around 1450 degrees centigrade. So with this temperature only, we can make the cement. So cement making process. So we have process, three processes. One is dry process and wet process and semi-dry process. So dry process and wet process are both different, but semi-dry process it is a combination of wet and dry process. Combination of wet and dry process. So if you can see this cement manufacturing process, especially for the dry. So this flow chart will show the wet process as well as the dry process. So we'll discuss about the dry process. So here, so you can observe the algerious materials, right? So this one and this one, calcareous materials, right? So we'll combine these two and we'll do crushing. We'll do crushing and grinding. Crushing and grinding. So if it is wet process, then it will the flowchart will follow this. If it is dry process, So after crushing and grinding, it will go to silos. Silos to again the grinding. So in the grinding process, we will add the water. We will add the water, and it will make the slurry. It will make the slurry. So both argillaceous materials and calcareous materials, and it will form a slurry. So then it will go to correcting basins to kiln, rotary kiln. So this is very, very important. Rotary kiln. So in the rotary kiln, so powdered coal and air will added here. And this after in the rotary kiln, it will form the hard clinkers. So cement will form like a clinkers, hard clinkers. So after that, we have to cool the clinkers. We have to cool the clinkers. So the clinkers will move to cooler. Clinkers will move to cooler, and in the ball mill, grinding will happen in ball mill. So in the ball mill itself, we will add 2 to 4% of the gypsum, 2 to 4% of the gypsum, and here the grinding in ball mill. So after this, it will go to storage silo. So cement will form here. So cement will form here, grinding in ball mill. So from this directly it will go to storage silo to packing, storage silo to packing. So this is the cement manufacturing process, right? So this is the flow chart, and this diagram shows the entire plant, chart of plant cement making, right? So limestone quarry. So here limestone quarry is there. So from the quarry, it will go to excavator to dump stock. So in the dump stock, you have the limestone rock, right? Then it will go to crusher. So that's what we have discussed here. The crusher, from the crusher to crusher to secondary crusher to the proportioning of the equipment. Here, sand and clay both will be there, so it will make the proportion different proportions. So both will mix here, proportioning equipment. So here in this process, we will mix both the fine ground limestone and the clay. So then it will go to grinding mill, right? So grinding mill to, so it will go to preheater tower, right? Preheater tower to, so again, so this is the kiln. Preheater tower to kiln, right? So from the kiln, it is go to cooling of the clinker. So that's what we have discussed, right? Coolers, clinkers will cool here. So it will add the gypsum also here, somewhere here, right? In the here we will add the gypsum. So from here it will go to grinding mill, final grinding mill. So in the grinding mill, cement will form here. The grinding mill, cement will form. So from here to silo cement storage. So you can see here cement storage. From the cement storage, it will go to shipping. So from here, this transportation will occur. So we can transport the cement from plant to required site. So this is the entire cement making plant. So this is the flow diagram for the wet process. This is the flow diagram for the wet process. So previously we have seen the dry process. Here this is the wet process. So wet process will have the limestone. So here we'll use the limestone and clay. So we'll mix the water, right? So it will go to elevators. So elevator to ball mill. So wet grinding will happen in ball mill. So here starting itself we'll add the water. So limestone, clay and water, right? So from the ball mill will happen the wet grinding. So wet grinding will happen in ball mill. So then it will become the raw slurry. So it will become raw slurry. So raw slurry to elevator to correction tanks to the rotary kiln. So here, so we'll add the pulverized, coal, and it will form the clinker. So after kiln, rotary kiln, it will form the clinkers, cement clinkers. So then it will go to grinding, right? So after grinding of the clinkers, So directly, so we'll have the silos, silos, cement silos to packing and supply. So this is what the wet process of the cement making, wet process of the cement making. So you can see here the diagram of rotary kiln, and this is the rotary kiln, and this is the ball mill. So this is the ball mill, and this is the rotary kiln. The cross section of rotary kiln and ball mill, right? So this is the wet process of the cement. So what is the difference between a dry process and wet process? Why we have two different processes? So what is the difference between these two processes? So dry process method means the manufacturing of raw materials into raw material powder whose water content is generally less than 1%. Generally less than 1%. So the dry process can reduce the heat loss needed by heating and autoclaving water. So but the dry process has its own flaw that it is a bad fluidity of the material grain in kiln. So it will cause the uneven mix. It will cause the uneven mix. So this is the for the dry process and wet process. In the wet process method of manufacturing raw material slurry with 30 to 40% of water content. So here in the dry process we'll use only less than 1% of water, but in the wet process we have to use around 30 to 40% of water content. 30 to 40%, 32 to 40% of water content. The wet process method is advantage is that it's good fluidity of the raw material slurry and makes more even mixed materials and produces the high quality of the clinker. So in case of dry process, we don't know high quality of the clinker because we are not using water in dry process. But here we are using wet process. We are using water content, so we will get the high quality of the clinker, but it requires more heat consumption, so it is not environmental friendly. So this is the main difference between a dry process and wet process. So what are the advantages of the dry process? What are the advantages of dry process? What is the disadvantage of dry process? And we'll see both. What is the advantages of wet process? What is the disadvantage of a wet process? So first we will see the advantage of dry process of cement manufacturing. So advantages, so labor productivity is increased. So in the dry process, the labor productivity is increased and low capital is required and fuel consumption is reduced in case of dry process, and modern day technology can help with the proper mixing of the material in dry form. So these are the main advantages of dry process. What are the disadvantages? So the dry process of cement manufacturing is very slow process. It is very slow process and it is costly also. And it is costly. So the cement produced is inferior quality that produces from the wet process. So we cannot ensure that quality from the dry process of the cement manufacturing. So these are the advantages and disadvantages of dry process. So let us see the wet process. What is the advantage of wet process? What is the disadvantage of wet process? So advantage of wet process, the cost of excavating and grinding of raw material is low here. So because we are adding the water and we are making the slurry here. So cost of excavating and grinding of raw material is low. Accurate control of consumption of slurry can be obtained here. So in the wet process, you can get very accurate composition of the slurry, right? So in the slurry can be made homogeneous. So we are mixing slurry. We are mixing both materials, right? So by using water, so you will make you will get more homogeneous material of slurry, right? A separate drying process operation is not required here. So here, separate drying operation is not required. So these are the advantage of wet process. So disadvantages, overall fuel consumption is very high in case of wet process. Fuel consumption is very high in case of wet process. So these are the advantage and disadvantages of both dry process and wet process of the cement manufacturing. So if you come to a dry process and wet process in a single this thing, first one is dry process and wet process. Here we are comparing. We are comparing dry process and wet process. So if we come to the dry process, materials are mixed in dry form. In the dry process, we will mix the materials in dry form. In the wet process, the materials are mixed in wet form because we are using water in wet process. The second one is raw mix is formed after mixing the material. So raw mix is formed after mixing of the materials. So slurry is formed after mixing of the materials because we are using water here. So here raw mix in dry process, and here in the wet process you will get the slurry. Wet process you will get the slurry. And third one is for producing 1 ton of cement. For producing 1 ton of cement, 100 kg of coal is required in case of dry process. For producing 1 ton of cement, 100 kg coal is required in case of dry process. In the wet process, for producing 1 ton of cement, we require 350 kg of coal is required. Producing 1 ton of cement, we require 350 kg of coal. 350 kg of coal is required in case of wet process. But in case of dry process, we are using only 100 kg of coal. We are using only 100 kg of coal. But in case of wet process, we have to use 350 kg of coal, right? And let's come to the fourth one. So materials have to be dried before use. Materials have to be dried before use. So material drying is not required in case of wet process, right? And fifth one, the harder raw materials can be used. So in the dry process, we can use harder raw materials can be used. Any type of material can be used in wet process. Any type of material can be used. Next one, high cost of production is incurred. High cost production is incurred in case of dry process. High cost of production is incurred in case of dry process. In the wet process, so we have the low cost production is incurred. Low cost production is incurred. Quality of the cement produced is comparatively inferior. So in case of dry process, we cannot ensure the quality of the cement. We cannot ensure the quality of the cement. So we can inferior, right? So in case of wet process, you will get a superior quality. In case of wet process, you will get superior quality of the cement is produced. In case of wet, superior quality of cement is produced. The similarities of both dry process and wet process are slurry is fed into rotary kiln for burning. So for both the process, slurry is fed into the rotary kiln for burning. So we have to make the clinkers, right? So burning and cooling as well as the grinding is done in both the process. So these two are both the process we need to do these two things. One is slurry is fed into the rotary kiln, and burning, cooling as well as the grinding has to be done in both the process. So if you see the comparison of these both dry process and wet process, so these are the comparisons and similarities of both dry and wet process of cement manufacturing. Cement manufacturing. So what are the chemical compositions? What are the chemical compositions of ordinary Portland cement? Ordinary Portland cement. So oxide compositions. So oxide compositions in ordinary Portland cement is one is CaO, calcium oxide, and SiO2, silicon dioxide, Al2O3, aluminum oxide, Fe2O3, ferrous oxide, right? So CaO is around 60 to 67%. CaO in the OPC is 60 to 67%. So it controls the strength, it controls the strength and soundness. So deficiency of this. So if you have a less CaO, deficiency reduces the strength and setting time. So if you have a less than 60%, the cement is having less than 60% of CaO. So then strength will reduce as well as the setting time also. So if you have a excess, so more than 67%, it makes a cement is unsound. Cement is unsound. So actually the CaO should be in between 60 to 67% only. So let's come to the SiO2 to silicon dioxide. So it should be around 17 to 25%. Silicon dioxide should be 17 to 25%. So it also gives the strength. It also gives the strength. So if you mix, if the cement is having excess, the cement is having excess of SiO2, so it causes the slow setting. Slow setting. So cement will set very slowly. So Al2O3 aluminum oxide. So it should be around 3 to 8%. Should be around 3 to 8% and responsible for. So the Al2O3 is responsible for quick setting of the cement. So it will set the cement very quickly. If you have excess, if you have excess in the Al2O3 is excess in the cement, it lowers the strength and setting time. So let's come to Fe2O3, gives the color, it helps the fusion. So Fe2O3 ferrous oxide, it will gives the color and helps the fusion. So MgO, so magnesium oxide, so it should be around 0.5 to 4%, 0.5 to 4%, imparts the color, hardness, and excess remains in free state. So if you have excess also, it will remain the free state. It will remain the free state, but it causes the cracks in cement. It causes the cracks in the cement and concrete. So MgO, if you have excess, it remains in free state, but it causes the cracks in the cement and concrete, and we can say cement MgO. So SO3 it should be around 1 to 2%. So SO3 should be around 1 to 2%. So it makes the cement sound, makes the cement sound. And alkalis, so Na2O and K2O, so sodium oxide and potassium oxide. So is these two are residues. These two are residues, alkalis. And if you have excess of this 0.4 to 1.3%, it causes the efflorescence and cracks. It causes the efflorescence and cracks. So these are the oxide composition of the cement, ordinary Portland cement. So cement, we have all these materials, chemicals, right? So thank you very much. So today we have discussed, we have started the module 1 and we have discussed what is the cement, what is the definition of the cement, and what is the cement making process, manufacturing of the cement. So we have two types of cement, two types of manufacturing. So actually three types. So one is the dry process and wet process, and third one is the combination of these two, semi-dry process method, right? And we have discussed the dry process, what is the flow diagram of the dry process, and we have seen the cement plant entire thing, how the process will be there for the cement manufacturing, and we have seen the wet process of the cement manufacturing, wet process cement manufacturing, and we have seen the flow chart, wet process of the manufacturing flow chart. So then we have discussed what is the difference between a dry process and wet process of the cement manufacturing, and we have discussed the advantages and disadvantages of the dry process as well as the wet process of manufacturing of the cement. So after that, we have discussed the comparison between the dry process and wet process, the cement comparison between dry process and wet process, and the similarities between these two processes, similarities between dry process and wet process, right? So after that, we have discussed the chemical composition of the cement. So especially we have discussed oxides in the ordinary Portland cement. So different oxides, and we discussed how much percentage it should be, and if you have excess, and if you have a lesser percentage, and what are the effects of those materials in the cement. So those things we have discussed in this class. So thank you very much for your patience.
Like, share and subscribe. Hit the bell icon for more updates.